Hello everyone and welcome back to another episode of Better Together at Science with Shinrai Sensei. And today we'll be kind of going over basics of wave mechanics. I know my art is fantastic, so I hope that you guys enjoy looking at it while I kind of explain the basics of wave mechanics. Alright, so wave mechanics, the main thing to know about waves is that they form in any fluid, right? So waves form in any fluid, form in any fluid that is disturbed or has energy added to it, right? We'll just go with is disturbed for a shorthand, right? But waves form in any fluid that is disturbed or that has energy added to it, right? Well, the proper way that you should probably remember is that it has energy added to it because that's more in line with the laws of physics. But we'll just go ahead and say that is disturbed for shorthand and brevity's sake, right? So wave mechanics, waves form in any fluid. Anything can form a wave that is fluid. Solids, obviously, they tend to be more brittle and they won't form waves because of the rigidity of their structure. They're more likely to just break. And that's actually the cause for a lot of the waves that we think of when we think like tsunamis. Tsunamis are the most famous kind of wave because they are caused by tectonic plate activity. So you'll have earthquakes causing tsunamis, but also impacts. Impacts and earthquakes cause tsunamis. Pardon me, I'm having a little issue spelling today, apparently. Cause tsunamis. Right? Those are the two phenomenon that will cause tsunamis. Right? Earthquakes and impacts cause tsunamis. Waves form in any fluid that is disturbed. So waves will form even by gentle disturbances, such as the currents in the air being transferred to the surface of the water will create waves that you experience as like the waves that people go surfing on are usually due to high winds over a coastal area. And obviously the waves that you're experiencing at the coast are exaggerated because the fluid ends at the coast, right? And so the waves that you're experiencing at the coast are because of, I'm going to draw it in, let's say, black to show like a black rock or something like that, or black coastal area. So I apparently can't spell coast either. Coasts or solid surfaces will act as a momentum stopper, right? And so the crest of the wave is going to be because something is slowing it down. So the energy is actually mostly right here, right? When the wave is out at sea, right? Like a tsunami, when it's out at sea, the wave, the energy is going to be, I'm drawing horrible waves, I know, but it's not nearly as fantastic as my piece of art up here. But these waves, right, the energy is actually here, right? That's where the energy is. And this is actually the energy from the next wave pushing forward on the wave ahead of it. So the energy of the water back here is trying to go faster than the energy of the water in front. And so it's actually the restriction of the fluid itself. The medium that the energy is trying to travel through is what's causing the waves, because the medium can't move as fast as the energy that is being put into it. And so the waves are going to be super small out here because the medium of the water is homogeneous, right? It's all the same. So the water is all moving together. And so even if the water does tend to get ahead of itself with a wave getting over the first wave, it's still all going to be moving together, right? It's not until it reaches a major obstruction that is the end of that fluid, either with a more dense fluid or with a solid surface like a coastline, that the energy stops right here, right? And so when the energy stops here, it builds and goes over here. It builds here, right? So when the energy stops here at the coastline, it's actually building up because the water is trying to keep going forward with the energy that it has built up. But it can't continue to push its energy directly at the front anymore, because now instead of being more water that just moves with it, now it's a solid that stops it. And so now, instead of the water just going like this, the water goes like this and then goes up like that. And so actually, the energy transfer is going to cause a walling up of that fluid until the fluid eventually reaches a point where it can't keep going up because of instability, and so it crashes down and will just flood over, and then eventually, obviously, the fluid will return to the lowest position that it can, which is what we call sea level, and the fluid will return back, right? And so you have like earthquakes, impacts cause tsunamis. Well, this is the exaggerated form of wave, right? The wave that is caused by something very deep in the water. So something maybe all the way down at the bottom of the ocean, right? Like the ocean's, the Earth's crust at the bottom of the ocean. If the tectonic plates slide all of a sudden, right? They're displacing all that energy of their motion will suddenly go up into the fluid above them and will cause the water to move up. And the tsunami will then move towards, out in a circle away from the epicenter of the earthquake, and will build up into a massive wave when they reach a coastline. And like I said, the energy stops at the point where the coast and the water meet, builds up, crashes down, and then the water will wash everything back. When it returns back to its lowest point where it wants to be, water always wants to be at the lowest point possible. When it does that, it will wash any unfortunate passersby, any unfortunate visitors of an area right by the coast. It'll wash all of you away. It'll wash everything away. Houses, skyscrapers in some cases will completely disappear because their foundation gets washed away and they get pulled out by the extremely powerful force that is, massive amounts of water. Water is an extremely powerful force. If you underestimate it, it will always get you. Impacts, obviously, those will displace massive amounts of water. And the thing that's also going to cause an extremely deadly tsunami isn't just the initial impact when the wave gets pushed out from where the, let's say, comet strikes the water. It's also going to be a massive tsunami when all that water comes rushing back, because now the fluid got disturbed twice, not just once. So an impact tsunami is going to be even deadlier than an earthquake tsunami, because the earthquake tsunami, really the most intense part of the tsunami for an earthquake should be the initial tsunami, right? But you have two major displacements whenever it comes to an impact, because the water gets displaced in the first place. When the object strikes the surface of the water, it's going to displace it all out. But then you have the major displacement of the water rushing back to fill the gap that the impact caused, and that will cause another major displacement of the water that will cause a second tsunami. Granted, it's likely to be less impactful than the first, but it's going to be very, very strong still. Whereas the earthquake tsunamis, unless the earthquake is like several small, incremental movements of the plate, the earthquake tsunami is going to be one massive wave with a few smaller recurring waves that just kind of finish damaging whatever the first big wave destroyed. And then the impact tsunami, you're going to have that first tsunami, small wave, then the second tsunami, and small wave. So But basic wave mechanics dictate that the fluids are going to move together, and if they are the same fluid, it's all going to move at the same speed. But once the fluid changes density, or once the fluid encounters a solid object, the fluid will attempt to displace its energy onto the solid object. The energy will build, 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 and then it will crest over and fall. So that's the basics of wave mechanics for a scientific perspective. The energy is actually right here at the front of the wave, but once that energy stops being transferred at the front, everything behind it is going to keep moving. Basically like the laws of physics, where it says that an object in motion will continue in motion until acted upon by an unbalanced force, right? And so waves are a very beautiful depiction of that law of physics. Anyway, I think that should be about it for basics of wave mechanics today. If you guys do have any questions, comments, or concerns, please leave them in the comment section below. Otherwise, peace. I'll see you in the next one.